a support bot gets a refund request. The model says, I need to check the order. The tool returns order not found. The model says, I should check the order again. Same tool, same result, again. 57 calls later, you have a bill, no answer, and a user still waiting. Nothing evil happened. The large language model, or LLM, was doing what it was asked. Choose the next step. The application programming interface, or API, worked. The missing part was engineering, state, limits, and a stop condition. The beginner version is usually one prompt and one answer. You send text to a model and hope the response is useful. That is fine for summarizing a paragraph or drafting an email. It breaks when the task needs facts from your system, multiple steps, validation, or decisions. The model may invent a tool name. It may return broken JavaScript object notation, or JSON, when your code expects strict fields. It may skip a required check because the prompt was long and fuzzy. The core problem is not that models are useless. The problem is treating a probabilistic text generator like a complete software system. Here is the clean mental model for this whole series. 1 API call, workflow, agent. It is a ladder, not a leap. A single call asks the model for one response. A workflow has predefined steps: classify, then retrieve, then draft, then validate. The model may help inside steps, but your code owns the path. An agent is different. It can decide the next step based on the current state. That freedom is powerful, but it is also where loops, cost spikes, and weird behavior appear. So we do not start with autonomy. An agent is not magic. It is a model wrapped in a harness. The harness gives the model a goal, a role, allowed tools, current state, and limits. In plain Python, the shape is boring. Run agent takes a goal and state. It builds messages, it calls a model. The model chooses either answer or tool call. Your code checks whether that tool is allowed, runs it, records the result, and loops. The loop stops when the model returns done, when validation passes, or when max steps, timeout, or budget is hit. The harness, not the prompt, is what makes the system survivable. Say you want to triage emails on your laptop. The simplest version is one call. Label this email as billing, bug, sales, or other. If that works, stop there. If you also need a draft response, make a workflow. Classify, then choose a template, then ask the model to draft, then validate that the label is one of 4 allowed values. Only consider an agent if the path truly varies. Maybe it sometimes needs to search local notes, sometimes ask a clarifying question, sometimes summarize attachments. Even then, give it only local test files, a max step count, and a clear stop rule. The trap most tutorials skip is that agent demos often succeed because the happy path is tiny. Real systems fail at the edges. The model returns almost valid JSON. It calls getInvoice with an email address where your function expects invoice ID. It decides to use a search tool when the answer should be I do not know. It keeps going because be helpful sounds like a goal, but is not a termination condition. More autonomy also means more testing. In my opinion, if a fixed workflow solves the job with fewer surprises, it is the better production design. This episode is the map for everything that follows. Prompt engineering helps you ask clearly. Context windows and tokens explain how much information the model can use. Structured outputs make responses parsable. Tool calling lets the model request actions, while your code enforces permissions. State and memory decide what carries across turns. Model selection controls quality, latency, and cost. All of those pieces sit inside the harness. When someone says agent, ask 5 questions. What is the goal? What tools can it use? What state can it see? What limits constrain it? And how does it stop? Try this safely on your own machine. Create 3 fake emails in a list. No real inbox, no third-party systems, no secrets. Write 1 call email that sends the text to your model and asks for 1 label. Then write workflow email. First ask for the label, then use normal Python if statements to choose a canned response. Then check the label is in an allowed set. Finally, write down what would have to change before you need an agent. Maybe nothing. That is a valid result. The skill is not adding loops. The skill is knowing when not to. Recap in 3 beats. First, an AI agent is not just a smarter prompt. It is a model inside a harness with tools, state, limits, and termination. Second, the latter matters. One API call, then workflow, then agent. Workflows follow predefined paths. Agents choose their next step. Third, most production agents are mostly workflow. And that is not embarrassing. That is reliability. New Agent Foundations episode daily, from first prompt to first agent. The paid libraries at aislabs.ai go deeper with production patterns, templates, and testable harnesses. Next, we make the first LLM API call and inspect what actually comes back.